Good morning. So we shall continue our discussion on partial differential equation, particularly non-linear partial differential equation. So the next is compatible system of first order equation. Compatible system of order equations. So consider a definition. So let's see a definition. This definition: two first order partial differential equation, two first order partial differential equations, say f of x comma y comma u comma q equal to 0 and g of x comma y comma q equal to 0 are said to be compatible they have common solution. If they have common solution. Now, so if these two partial differential equation have common solution, then we say these two partial differential equations are compatible. So let's take this equation one, that is f of x comma y comma u comma p comma q equal to 0 as equation, and g of x comma u comma p comma q equal to 0. Now we shall try to derive the condition, necessary and sufficient condition for compatibility of these two equations, necessary and sufficient condition for compatibility of these two equations. So if dou of in respect to dou of p comma q is not equal to dou of f comma g divided by dou of p comma q is not equal to 0, then we can solve 1 and 2 for p and q and obtain an explicit expression. So this we have seen in the beginning of our Papian differential equation. Say we get the expression p is equal to say phi of x comma u, and q is equal to say z of x comma y comma u. Say these two are equation p. The condition that the pair of equation, these two equation 1 and 2 should be compatible, reduces then to the condition that the equation, so compatibility of this reduced to check the integrability of p dx plus q dy equal to du should be integrable. Compatibility of checking whether these two equations are compatibility of these two equations, condition for compatibility of these two equations is reduced to checking integrability of this equation. Now we know that that is p is nothing, so it is phi y u plus d of y u minus du equal to 0. So let's call it. Now we know that again, using our discussion from the Papian differential equation, the integrability of this is got by with the condition x dot curl x equal to 0, where x equal to here it is phi comma z comma minus 1. So let's verify x dot curl x equal to 0. So before that, let's find out what is curl x. So it is now I hat, j hat, k hat, dou by dou x, dou by dou y, dou by dou u, and now x is phi xi minus 1, so it is phi xi minus 1. So determinant of this is nothing but now again the first component is differentiation of minus 1 with respect to u, so it is 0, minus differentiation of xi with respect to u, that is xi u, comma differentiation of phi with respect to u, so it is u, minus differentiation of 1 with respect to minus 1 with respect to x, it is 0, comma differentiation of xi with respect to x, so it is xi, minus differentiation of with respect to y, so it is y. So that is we have, which is nothing but minus xi u, comma phi u, comma xi x minus phi y, phi y. So therefore x dot cap equal to x is nothing but phi xi minus xi u, comma phi, comma xi x minus y, phi y, that is phi into xi u, it is minus phi into xi u, minus phi into xi u, plus xi into phi u. Yeah, sorry, I'm not correct. See, phi into minus xi u, so it is minus phi into xi u plus xi into phi u, so it is xi into phi u. Next it is minus, so it is minus xi x plus phi y. So the the equation, so wait a second. So this is this differential equation integrable if and only if x dot curl x equal to 0, that is x dot curl x equal to 0, that means this x dot curl x equal to 0 implies this equation equal to 0, that is so when this equation is equal to 0, we have zx plus zx plus zx plus I think we made a mistake, some mistakes. Yeah, okay. No, mistake, I think. Is equal to 0. Xi x, where it, yeah, xi x, and taking this the other type. Okay. So we shall write once again. That is this implies minus phi u plus xi into phi u minus x plus phi y equal to 0. Now just rearranging, that is into phi u plus phi y, xi into phi u plus phi y, which is equal to, now the remaining is phi into xi u, taking this to other type, is plus xi x. Yes, okay, correct. So we have now this relation. Let's do this equation 5. We shall now get the expression in terms of f and g, because this equation is now is in phi and xi, so I need in terms of f and g. So for that we shall substitute this for that we shall substitute this equation 3 in equation 1 and 2 and differentiating partially with respect to y and u, equation 1 and 2 are differentiating with respect to 1 and 2. So substituting 3 in 1 and 2 and differentiating partially with respect to y, we know f to y plus again f is a function of p, so it is f with respect to p and p with respect to y, but we know that now we know that p is nothing but phi, and xi. So remember, so fp into p with respect to y is nothing but phi y plus f with respect to q and q with respect to y, so q is nothing but xi y to 0. Similarly with respect to u, so it is fu plus fp into phi u plus f into xi u equals 0, and g again differentiating that's the second equation, g with respect to y and u, so it is gy plus again g with respect to p into p with respect to y. Now p is nothing but phi, so it's phi y plus g into q xi y equal to 0. Again g with respect to u plus g with respect to p and q phi with respect to u plus g with respect to q and phi with respect to xi with respect to u equal to 0. So let's name this as equation 6 and 7, 8, and this is 9. now equation 6 plus xi into 7 into equation 7 gives so to equation 6 just add xi into 7, so we have fy plus fp into phi y plus fq into xi y plus xi into 7, so it is now xi into fu plus xi into fp phi u plus xi into fu xi u equal to 0. Now this gives now see fu combine fy plus xi into fu plus fp into taking common term, that is now phi y plus it is xi into phi u plus fq into, so fq into now xi into fq into xi u equal to 0. So let's this is equation 10. Similarly 8, this equation 8 plus xi into equation 9 we get now, see, so combine, so we get gy plus xi into gu now plus now gp into phi y plus xi into phi u plus now gq into xi plus xi into xi u equal to 0. So let's take that equation 11. Now from this equation 10 and 11, g into q into equation 10 minus fq into equation 11 gives, so just multiply this equation by gq and this equation by fq and subtract, we get so it is gq into this, that is gq into fy plus xi into fu. So just multiply this equation first by gq plus gq into fp into phi y minus xi into phi u plus GQ into FQ into ZY plus to ZU. Now subtract by Q into 11. So just multiply this equation by minus FQ. So it is minus FQ into GY plus 5 into GU plus again it's minus, sorry, GP into 5Y plus Z into 5U minus FQ into GQ into ZY plus Z into ZU equal to 0. Now observe GQ FQ ZY plus Z into ZU, GQ FQ ZY plus Z into ZY with opposite sign, it cancels. Now from these two, combining these two, we have GQ into FY, GQ into FY minus FQ into GY and the remaining two term here if Z is common, so plus Z into GQ into FU minus FQ into GU. So now we remain with these two equation. Here now these two terms are again common. So plus 5y Z into 5u into now it is GQ FP minus Q into GP 0 equal to 0. Now observe this term is nothing but it is dou of Q comma F divided by dou of G comma F divided by Q comma Y plus Z into, now it is dou of G comma F divided by dou of Q comma U plus now this term is again it's 5y plus Z into U into, again this is nothing but dou of G comma F divided by dou of Q comma P. Yes, yeah, correct, equal to 0. Now just rearranging, that is, now this can be written as dou of F comma G, so it is multiplied by minus 1, so I am changing denominator also, so it is F comma G by Y comma Q, so plus now Z into dou of again F comma G, so it gets multiplied by minus 1, so when I get this reverse by divided by dou of U comma Q, so minus get cancelled, again plus x 5y plus Z into 5u, so it is dou of now F comma G divided by dou of P Q equal to 0. So just recall this definition of this from your previous class if you forgot. So now from this this is equal to, that is 5y plus Z into 5u is equal to, now this when I take this to other side I get minus 1, so it's minus 1 divided by, so it is dou of F comma G divided by dou of P comma Q. This is clearly not equal to 0. Now we have this is not equal to 0, therefore this multiplied by now, so to term, that is dou of F comma G by dou of Y comma Q plus Z into dou of F comma G divided by dou U comma Q. See, let's take it as equation number 12. Now similarly we just differentiated my equation 1 and 2 with respect to y and comma u. Now we shall differentiate the same thing with respect to x and u. We get so differentiating with respect to x, differentiating 1 and 2 with respect to x and u, we get so this is the next part, that is f plus fp into phi x plus fu into xi x equal to 0. Similarly, fu plus f into phi u plus fu into u equal to 0. Similarly, with respect to g, that is g of gx plus g into phi x plus gq into phi xi x equal to 0, and gu plus gp into phi u plus gq into xi u equal to 0. Let's name this as 13, and this is equation 14, and equation 15, and equation 16. So similarly, following above procedure once again, that is now equation 13 plus 5 into equation 14, equation 13 and 5 into equation 14, we get now the so we get fx plus 5 into fu, so 5 into fu plus now fp into xi x plus 5 into phi u plus fq, so fu into xi x plus 5 into xi u equal to 0. Similarly 15, equation 15 plus 5 into equation 16 gives now it is g plus 5 into gu plus gp into phi x plus phi u plus gq into xi x plus phi into xi u equal to 0. We shall name this 17, and this is equation 18. Now then calculate g into equation 17 minus f into equation 18. Multiply this equation 17 by g and equation 18 by fb and subtract. So we get so when I multiply 17 by gp, that is gp into fx plus 5 into fu plus now gp into fp into phi x plus 5 into phi u plus gp into fq into xi x plus phi into xi u minus, so we shall not write that now. Wait a second. So now multiply by minus fp to the equation 18. So it is minus fp into g of x plus 5 into gu minus fp into gp into phi plus 5 into phi u. Next again is minus fp into gq into xi x plus into xi u equal to 0. Now from this, just combine this term, that is we have gp fx minus fp gx dx. Now combine these two terms, again phi is common, so it is plus phi into this. I think somewhere in this, yeah, no, correct, yeah. So it is phi into combining these two, so phi is common, phi into gp into fu minus fp into gu. Now observe gp fp phi into phi u, phi x plus phi into phi u, these two get cancelled, so now I remain with these two again, fq, these two terms are common, so we have it is plus it is gp fq minus fp gq whole multiplied by xi x plus into xi u equal to 0. Now this is nothing but dou of now it is f comma g divided by x comma p plus phi into, now again it is f comma g dou of divided by dou of u comma p plus now this is nothing but dou of f comma g divided by dou of f comma g divided by dou of q comma p into xi x phi into xi u equal to 0. Now this is as it is, dou of f comma g by dou of x comma p into phi into dou of f comma g divided by dou of u comma p. Now it is dou of f comma g. Now just interchanging this, so it gets multiplied by -1, so therefore it is minus dou of p comma q into xi x plus phi into xi u equal to 0. This gives, now this since again this is not equal to 0, we get now xi x plus phi into xi u is equal to so 1 by dou of f comma g divided by dou of p comma q into dou of f comma g by dou of x comma p plus phi into dou of f divided by dou of u comma p. So we got two expressions of equation 5. We got this, the left hand side expression as well as a right hand side expression, that is one is this and another one is this. Now substituting in equation 5, so therefore my 5 gives 1 by dou of f comma g divided by dou of comma q into that is dou of f comma g divided by dou of x comma p plus phi into dou of f comma g divided by dou of u comma p is equal to -1 dou of f comma g divided by dou of p comma q into dou of f comma g divided by dou of y comma q plus phi into dou of f comma g divided by dou of u comma q. Now so cancelling the common terms and rearranging, we get dou of f comma g divided by dou of x comma p, that is this term, plus now it is phi into dou of f comma g divided by dou of u comma p. Now taking this to another this side, we get it is plus dou of f comma g divided by dou of y comma q plus again z into dou of f comma g divided by dou of u comma q equal to 0. That is dou of f comma y comma g divided by dou of x comma p plus, now phi is nothing but p, so it is p into dou of f comma g divided by dou of u comma p plus dou of comma g divided by dou of y comma q plus q into xi is nothing but q, so it is xi q into dou of f comma g divided by dou of q dou of u comma q is equal to 0 is equal to 0. Therefore, necessary and sufficient condition for equation 1 and 2, that is nothing but my f of x comma y comma u comma p comma q. There is a partial differential equation, and g of x comma y comma u comma p comma q equal to 0 to be compatible is equal to 0. F comma g equal to 0. So now this is nothing but this expression, that is 0. So let's take a problem. Show that the equations xp minus yq is equal to x and x square into p plus q, which is equal to xp, are compatible, and find their solution. So let's they are given two PDEs, say f of x comma u comma q is equal to xp minus yq minus x equal to 0, and another PDE of x comma y comma u comma p comma q is given by x square into p plus q minus x into u equal to 0. Let's take this as equation 1 and this as equation 2. Now we shall verify, let's check this condition whether this f comma g equal to 0. If it is equal to 0, then these two equations are compatible. So to that, let's find dou f comma g divided by dou of x comma p. First, this is the determinant of fx and xp and gx gp must be determinant of must be equal to 0. That is it must be this is nothing but that Jacobian. Dou of f comma g by dou of x comma p is nothing but determinant of fx fp gx gp. So now fx is nothing but differentiation of this f with respect to x is nothing but it is p minus 1. Now with respect to p it is x. Now g differentiation of g with respect to x is 2xp minus u, and with respect to p it is just x square. So if we multiply, that is find the determinant, that is x square into p minus x square minus 2x square p minus u into x, that is nothing but x square minus 2x square p is nothing but, so it is minus x square p minus x square minus u into x. Similarly, dou of f comma g divided by dou of u comma p is again similarly determinant of fu fp gu gp, which is equal to, now fu derivative of f with respect to u is nothing but it is 0 because f is independent of u, so it is 0. Now differentiation of f with respect to p is nothing but now just it's the x. Differentiation of g with respect to u, it is nothing but minus x. Differentiation of g with respect to p is nothing but is x square. So this is nothing but 0 minus of x square, so it is plus x square. Similarly, differentiation of f comma g with respect to now it is y comma q dou f comma g by dou of y comma q, that is equal to, again it is determinant of f q and gy gq, which is equal to, now differentiation of f with respect to y, f with respect to y, so y it is nothing but minus q, so it is minus q, and with respect to q it is minus y. Now differentiation of g with respect to y, it is again 0, and with respect to q it is again 1. So this is nothing but now minus q. And the last one, that is differentiation of dou f comma g divided by dou of determinant of f u f q and g u and g q, what is equal to now differentiation of f with respect to u, it is again 0, and fq it is minus y, gu is nothing but minus x, and gq is nothing but 1. So we get it is nothing but minus x into y. So therefore f comma g, which is equal to dou of f comma g divided by dou of x comma p plus p into dou of f comma g into dou of x u comma p plus dou of f comma g divided by dou of y comma plus q dou of comma g divided by dou of u comma q. Now this is equal to now substituting dou of f comma g divided by dou of x comma p. This is nothing but now minus x square p minus x square minus plus ux plus plus minus plus q plus y. Now it is x square p minus x square p, x square p it cancels, so we have now minus q square plus ux minus q xy. But we have f is nothing but first equation, that is f from the equation 1 we have xp and we shall consider it from equation 2 we have x is equal to x square p plus q, x square p plus q. So just to substitute here, so it is minus x square plus ux is nothing but that is x square p plus q. So it is x square plus q minus q x square as it is. So plus minus q cancel. So we have now plus x square plus x square minus now we have it is qxy. So just rewrite it minus x square p and minus now x into it is q into y. Now wait a second. From equation 1 we have q into y is equal to xp minus x. Q into y is equal to xp minus x. So this becomes minus x square minus x square p minus x into, now this is nothing but x minus x. So we have minus x square minus x square p minus x square p. I think somewhere mistake, yeah, it's plus minus plus x square. So this get cancelled, is equal to 0. Therefore we got this expression is equal to 0. Hence my given two PDEs are compatible. Therefore 1 and 2 are compatible. Therefore the given PD are compatible. PDs are compatible. So now we shall find their solution. So to find their solution, we shall now just solve 1 and 2. That is these two equations. Given two partial differential equation 1 and 2 for P and Q. We have wait a second. We have x minus yq minus x equal to 0 and x square p plus q minus xq equal to 0. Now, so this was equation 1 and this is equation 2. Now just Here I have yq, here I have just q, so just multiply this equation by y and add it to this equation. We get that is we are adding 1 plus y into 2. So 1 in the beginning we have taken this as equation 1 and this is equation 2. It gives now it is xp minus x plus x square yp minus xyu equal to 0, xy equal to 0. Now combining these two terms and these two terms separately, we have now see when combining these two terms, xp are common, so we can take it out. So it is xp into 1 plus, so it is again xy which is equal to, now taking to other side and taking common, that is x is common, so it is 1 plus y into u. Now from this we have p is equal to 1 plus y into 2 divided by 1 plus x into y. Now substitute this p is equal to 1 plus yu by 1 plus x square and x square in equation 2. For q we have q is equal to now it is x into u minus x square into p. So just substituting p is equal to 1 plus y into u divided by 1 plus x into y. So now solving, so it is x into this, so it is x into u plus x square u into y minus x square y u. So this to get cancelled, so we have now divided by 1 plus y, so which is nothing x into u minus x divided by 1 plus x into y. So we have now p and q expression for p and q. Now we shall solve the Papian differential equation. Solve the Papian differential equation x plus 2y equal to du. That is now p is nothing but 1 plus yu divided by 1 plus xy plus yu divided by 1 plus x into y into dx. Now q is nothing but x into u minus 1 plus x into y dy equal to du. That is this gives 1 plus u into dx plus x into u minus x dy, because denominator common, minus 1 plus x into y du equal to 0. Now we shall solve this differential equation using one of the method which we have studied in the beginning of our discussion. So we shall so for the timing I will take Nathani's method to by treating x as constant. My equation, say this is equation 5. So this equation 5 reduced to equation 5 reduced to, so taking x as a constant, equation 5 becomes, so it is x into u minus x dy minus 1 plus xy into du equal to 0. That is, this gives so dividing throughout by x into u minus x into 1 plus xy, we get it is dy divided by 1 plus xy minus du divided by x into u minus x, which is equal to du. Now this gives x into dy, just multiply by x, you will get x by dy divided by 1 plus xy minus du divided by u minus x equal to 0. So just divide by u minus x into plus xy. So you will get directly this equation without going to here. So now since x is a constant, now this gives this is nothing but y divided by 1, so, because x is a constant, minus if it is differentiation of minus x divided by u minus x is equal to 0. So on it is integration ln of xy minus ln of u x is equal to tan c, that is we have xy divided by u minus x is equal to c, u minus x is equal to c. So we seek a solution of equation. We are finding the solution of equation 5, but I just got by treating x as a constant. So equation of 5 is of the form. Therefore, solution of 5 of the form. So we are interested to find the solution of the form 1 plus xy divided by u minus x is equal to xi of x, where xi is a function of x alone. Now taking so this is a procedure I am following from Newton's method. If you are confused, just go through Newton's method once again. Now taking y is equal to 0 in say this equation 6. In 6 we get 1 by u minus x is equal to xi of x. Just take as equation 7. Now taking y is equal to 0 in 6 we got 1 by u minus x is equal to xi x. Now when I take y equal to 0, my equation 5, that is a partial differential equation, this is reduces to say plus y is 0, so 1 to dx. Now this is 0 and y is 0, so it is du. So I got dx minus, we have dx minus du equal to 0. We have dx minus du equal to 0. So 5 becomes dx minus du is equal to 0. So on integration we get it is y minus x is equal to say some c1. So just I'm just rearranged. So actually it is x minus u is equal to a constant. So just change the constant to new constant and rename it as y minus x, rewrite as y minus x is equal to c. Now observe that this is the solution. Say this is now equation. So this is equation 8 and this is equation 9. So this equation 9 is a solution. This equation 9 is a solution equation 8. Similarly, equation 7 is a solution of equation 8. Both 7 and 9 are solution of equation 8. Therefore these two solutions, these 7 and 9, these two solutions must be equivalent. That is 7 and must be equivalent. So we shall just eliminate u between 7 and 9. So u minus x is equal to c1, and therefore we get xi of x is equal to 1 by c. We get xi of x is equal to 1 by c. Now just substituting for equation 6, xi of x is equal to 1 by c. We get 1 plus x by y divided by 1 plus xy divided by u minus x is equal to 1 by c. This gives u minus x equal to plus xy. We get u x plus c into 1 plus xy is a solution of 1 and 2. That is my given partial differential equation 1 and 2. Hence the solution. Thank you.